are looking at finding the zeros of a given polynomial. This is an application of the factor theorem. Now let's take a recap of the factor theorem. Remember that if f of x is divided by x minus a, giving us g of x plus r, we said that number one, the remainder theorem will say that f of a is r, and then number two, f of a is 0, factor theorem, where x minus a is a factor. Remember that? Good. Now, finding the zeros of a polynomial. Every polynomial may or may not, but most of the time, a polynomial may meet the x-axis at a given point, and we call those points the what? The zeros of the polynomial. Now, the number of zeros of every polynomial is equal to the order or the degree of the polynomial, so that for a linear function ax plus b, we have only 1 0, okay, because the degree is 1. For a quadratic, we are going to get 2 zeros. For a cubic function, we are going to get 3 zeros. Let me give you a visual representation of this. So for our linear, we have our ax plus b. Now, we see our function meeting the x-axis at only one point. We call it the x-intercept, and that is the 0 of the function. If you put x1 in the function, we are going to get 0. That's for the linear. Now for the quadratic. This is a linear function. For the quadratic, function, we are going to have 2 zeros, x1 and what? x2, okay? So we have 2 points where the function meets the x-axis. Now, if we find f of x1, we should get 0. And if we find f of x2, we should also get 0. What about a cubic function? Your guess is as good as mine. 3 zeros. x1, x2, x3. All right? And we'll see that f of x1 is 0, f of x2 is also 0, and f of x3 is 0. Now, our objective for today is to find the zeros of a given function, polynomial function, and factorize it completely. All right? Okay. We are using the factor theorem. We are using the factor theorem for this. All right. Now, most of the time, we can use that and then synthetic division or long division. So let's begin with an example. Show that x minus 1 is a factor of f of x is equal to x cubed plus 5x squared plus 2x minus 8, and hence find the other linear factors of f of x. Okay, show that s minus 1 is a factor of f of x, and hence find the other linear factors of f of x. How are we going to go about this? We start with our preamble. If x minus 1 is a factor, then what is x minus 1 equals 0? X equals 1. Then f of 1 should be what? Should be 0. So let's plug in 1. Let's put 1 into our function. F of 1. We have 1 cubed plus 5 times 1 plus 2 times 1 minus 8. We have already worked this in the previous example, the previous video. You can go and check. So we have 8 minus 8, and we have what? 0. So therefore, x minus 1 is a factor. So the next thing we are going to do, that if x minus 1 is a factor, now if you divide a number by a factor, you get another factor. 6 divided by 2 gave us 3. 3 is a factor, and then 2 is also a factor. So one way to find another factor is to divide the function by something that is already a factor. So now we are going to divide our function f of x. We are going to divide it by x minus a. Okay? What is our function? Let's go back to our question. Our function is x cubed, sorry. Our function is x cubed plus 5x squared plus 2x minus 8. And our divisor is x minus 1. So we're going to divide. We're going to divide f of x by x minus 1. You can use long division or synthetic, but let's use synthetic division. I hope you've already watched the video of synthetic division. If not, go and look for it and then watch it. All right. Okay. So we have our synthetic division lines. Now let's put our coefficients there. 1, 5. I'm looking at the coefficients of f of x. 1, 5, 2, and negative 8. 1, 5, 2, negative 8. We have to always make sure that the coefficients have the correct degree, or the correct negative or positive. And then x minus a equals 0 gave us x to be what? 1. So we put our divisor here, 1. So we start by dropping our 1. 1 times 1, 1. 5 plus 1, 6. 1 times 6, 6. 2 plus 6, 8. 1 times 8, 8. Negative 8 plus 8, of course, our remainder will be 0. Now, since we have a power of 3 divided by a power of 1, we are going to have a power of 2. So our degree is going to be 2. So we are going to have a quadratic x squared plus 6x plus 8. And that is our quotient. It is also a factor. Now, since this is a factor, let's factorize it. To factorize it, we are going to get two values of x, the sum of which will give us 8, and the product will give us, sorry, the sum of which will give us 6, the product will give us 8. The sum of which will give us 6, the product will give us 8. What are those two numbers? I believe we are looking at 4 and 6. Yes, 4 times 2, sorry. 4 times 2. 4 plus 2 is 6. 4 times 2 is 8. Let's substitute x squared plus 4x plus 2x plus 8. So we can do factorization by grouping. We have x squared plus 4x plus 2x plus 8. Let's factorize by grouping 2 at a time. X out, x plus 4 plus 2 out, x plus 4. And so we are going to have x plus 2, x plus 4. So therefore, the other factors, the other linear factors are x plus 2 and what? X plus 4. And so if we were to completely factorize our function f of x, we'll pick the first factor, x minus 1, the second factor, x plus 2, and the third factor, x plus 4. If we were to find the zeros, we would say that x minus 1 equals 0, x equals 1. The second one, x plus 2 equals 0, x equals negative 2. The third one, x plus 4 equals 0, x equals negative 4. And so the zeros of the function would be, negative 4, negative 2, and 1. Okay, why don't you try this example? Why don't you try this example? Find the zeros of f of x is equal to x cubed plus 7x squared plus 4x minus 12. Try it and let me know what you think in the comment section. Thank you.